Yeah. Hello, everyone. I'm happy to be here. I'm first time in the US. I'm first time in San Francisco, and I'm first time speaking in such big audience. So yeah, a little bit nervous. Thank you, thank you, thank you. First of all, let me introduce myself. My name is Boris. I am, it's hard to say, engineering manager at database reliability engineering team. It's very long because I have been working as a site reliability engineer for 2 years, and for last year I dedicated myself to databases. So we converted our team from just DBA to database reliability engineering team to follow some SRE practices. Yeah, I'm going to tell you today a story about our journey from MySQL to TiDB. A story of why we choose TiDB. Why MySQL doesn't fit both requirements anymore, all challenges that we have during migration, where are we now with TiDB, and what is the future of TiDB. Actually, I can talk about TiDB for many hours, but unfortunately I have only 20 minutes, so let's start. Before I jump into the topic, I want to tell you a little bit more about Bolt, because it's a little bit confusing that actually there is another Bolt here in the valley, which do payments. We don't do payments. We located in Estonia, in Europe, and we have like more than 100 million customers across all the world. And the Bolt is one of the fast-growing company in the world, which is quite impressive. Okay, so at Bolt we have 5 core products. The first one is ride-hailing. You may say that we are just like Uber. I can tell you that, yeah, we exactly like Uber, but we are better. Yeah. Also, we have micromobility, which is basically scooters and bicycles. And we have like more than 200,000 of scooters, which is basically Internet of Things. And we also have Bolt Drive, which is car sharing, and 2 delivery services. One is Bolt Food, which is delivery from restaurants, and the last one is Bolt Market, which is delivery from grocery stores. But what all of those services mean to me as an engineer? Data, a lot of data, all services, all business lines produce many terabytes of data, and they're coming like every moment, like a few gigabytes. Yeah, it's not a surprise because we have many developers at Bolt, and they write code and build microservices, and we have many of them actually. They're running Kubernetes, but that doesn't matter much. Almost every second microservice has its own database. Yeah, and since we run fast at Bolt and should run faster than competitors, developers do hundreds of deployments every day, and most of them depends on changes in databases. Yeah, many microservices, 5 business verticals. We have, at Bolt, we have principles, and one of those is that our decisions are data-driven. That means that, like technically, that means that we replicate almost everything from our databases to the data lake with Kafka to basically to allow business make data-driven decisions. And we use AWS. We don't use any managed services. We run everything self-hosted on EC2 instances, mostly because of cost efficiency reasons. Yeah. So now turning to how to keep databases up and running with so much data. And we actually were quite happy with MySQL for a long time. And like 2 months ago, Bolt actually turned 10 years. So we have been using MySQL for 10 years already. But one day we found that we grew too big for MySQL. I divided the major reasons into 3 groups. Most of them are well known, but some of them are like specific for Bolt. So the first group is about data size. InnoDB, we use InnoDB as a database engine with MySQL. InnoDB isn't very happy about 8 terabyte database or even 5 terabyte database, depends. It's hard to scale, it's hard to backup, it's hard to maintain. Speaking of data growth, MySQL is a single instance. MySQL master is a single instance, and to get the best I/O performance, we use instances with local storage with NVMe disks, and it's not easy to scale them because you have to rebuild like replicas with larger instance type, do master switch, which can cause downtimes. So yeah, it's like complicated sometimes. Yeah, and the last picture on the slide is about an important thing which is usually hidden behind the operational routine. It's backups. So basically, when you have 8 terabyte database, we use Percona Extra backup for backups. But like, okay, you can backup it fast, but in case of disaster, it may take hours to get data back. And basically, during this restoration process, your application will be down, which is not acceptable. And the next group is maintenance. Yeah, as I said, that master switch causes downtime. And since we are like in a basically real-time business, we got orders like every seconds, and we have to process it. Then that means that master switch causes downtime and causes some financial losses. We use for DDLs we use Ghost tool, or Percona Online Schema Change is basically do the same thing. And for some operations, it may take up to 2 weeks to apply some changes for those tools. If you're familiar with those tools, then you know that basically it does like shadow coping of your table. But after it finished, then you need to drop previous table. And MySQL designed in a way that when you do drop table, basically main thread of MySQL can be freezed for seconds, and this is also not acceptable for us. Even if you do it with magic, with hard link to reduce the load on I/O. And the last item actually is very actual this month, because MySQL 5.7, which we are using, is going to end of life this month, I guess. So upgrade is not easy. It's not hard, but it's not easy. If we are speaking about upgrade from 5.7 to 8 to MySQL 8, then it's tricky because it's hard to roll back. It has many changes in optimizer, so you have to be prepared very well for this operation. Yeah, and another very example from real life. It's how MySQL do connection handling. On this picture, you can see that we had a spike of new incoming connections to our MySQL master, and you can see that almost 600 or 6,000 incoming connections are in other state, which means basically that MySQL master wasn't operatable that time. It's just because of MySQL design and how it handles connections, incoming connections. It has like a queue in main thread, and only after processing this queue, it creates like a separate thread for your new connection. We also are looking at other options, and we start with Vitess, and we actually had one installation of Vitess, one cluster of Vitess, but it still has MySQL inside with same issues that we have right now with just pure MySQL, but it also has some additional things like VT Gateway, which adds additional complexity. And you need to deploy it somewhere, maintain it, and so on. And application should know about sharding. So basically, it requires some changes in code and actually big changes. We also were looking at other database engines like Postgres, MongoDB, Aurora. For Postgres, SQL syntax is different. Like Mongo is too much code to change, and Aurora is just too expensive at our scale. Now, what about TiDB? Yeah, many things in the list. Let me go through it. Yeah. Very famous picture from the documentation, and actually it's about scalability. This is the reason number one why we choose TiDB. Because it's scalable by design on different levels. Probably you know that you can scale access layer, which is TiDB, and storage layer independently. It's very elastic. You can add a node, you can remove node dynamically. So yeah, that was the reason number one. Yeah, so it's elastic, and it also impacts our costs. The next thing is efficiency. Efficiency on different levels. First level is resource usage efficiency. So we found out that actually TiKV has a compression, and actually one guy from Meta spoke about this today already. And on our first migration from Vitess to TiDB, we migrated like 4 terabyte database to TiDB, and it turned out that now it's like 1.5 terabyte. So actually, it's quite impressive. And from our experience, average compression rate is about like 2. Sometimes it's more, sometimes it's less. It very depends on data or table structure. But anyway, it's like very nice thing. The next thing is that TiDB supports ARM architecture, and we actually run our TiDB clusters only on ARM. And it's cheaper in AWS, and it's real CPU core without hyperthreading, which is especially important for TiKV. And the third level of efficiency is maintenance efficiency. So we don't need to care anymore about this ghost without babysitting DDLs because like they built in and managed by TiDB itself. We don't need to switch master because it's multi-master. Backup, you can parallel it because it can push data from multiple TiKV nodes at the same time, and the same thing about restoring. And it's cloud native, so many tools which TiDB provides or PinCap provides, they support cloud like S3 or Kubernetes operator. And last but not least, yeah, this topic was like partially covered today already many times. That TiDB is open source. The development process is transparent, code is available, you can change it, you can build it, you can hack it, and it will work. You can build your own binary, and we actually do it or did it in the past, or to fix some bugs like more quickly than they were released. And yeah, but do you know what can make open source project even better? Do you? Yeah, I know the answer. The answer is community. There are a lot of good examples of open source, like Linux, Ubuntu, Kubernetes, with a very solid community. And here I want to tell you that actually Bolt and PinCap do an incredible work together. So since, yeah, in Tallinn, Bolt hosted the first meetup in Europe almost 1 year ago. And since then, we have more than 20 meetups in Europe. And Bolt actually took part in 10 of them. By the way, the next meetup in Tallinn will be on 11th of October. So please join. Yeah, if you want to have the same jet lag as I have. Yeah, there will be recording, there will be broadcasting, and you also can find all recordings from previous meetups that we have in Tallinn there on YouTube, on PinCap channel. Yeah, and actually, you know, guys, that I really believe in open source, and I really believe that like we here we are the community, and we can make TiDB even better together. Oh, I don't remember this slide because we don't have any challenges with TiDB. Yeah, hard to believe, right? Okay, yeah, we actually had. Yeah, actually, the biggest challenge, at least for me, because I'm not like a database guy. I came to database world from SRE, and I worked previously with like old technologies, and it was very hard to me to change mindset from a primary replica narrative to this distribution nature and so on. So yeah, it's like my honest advice. Please read documentation, which is actually quite good of TiDB, and try to understand the main principles of distributed database architecture before you actually start using it. Another challenge was that actually MySQL compatible doesn't mean that it actually MySQL. It has some limitations. They are also mentioned in the documentation. But yeah, before start using it, you should know them. Yeah, the next thing is that multi-master is like easy to understand, but not so easy to explain to clients. For example, they used to run heavy queries on MySQL read replicas. But with multi-master and with TiDB, if you run like a heavy query, then it may affect writers as well. Yeah, some challenges, like I said, they're about mindset, but some of them are very practical. And for example, downside of distributed architecture, you may see increased latency because of more network communication between different database components. But yeah, the good news is that TiDB also is moving fast, and you actually need reread documentation like every 6 months or something like that to catch up on all new things. And one of those actually auto-increment and auto-increment behavior in TiDB. That was probably the biggest challenge for us in the beginning because prior to 6.5 TiDB version, TiDB doesn't support monotonic auto-increment, which means that you cannot predict primary key value for rows that you are like inserting. We solved this issue with additional timestamp column. But unfortunately, our application, they rely on queries with order by ID, basically. That's not very good pattern, but yeah, it is what it is. So they have to rewrite a lot of queries to change ordering by this new timestamp column. But yeah, since TiDB 6.5, you can create new tables with autocache ID equals 1. It's like a scroll hint. And after that, your table will behave the same as MySQL. Unfortunately, you cannot convert this behavior once you create table, but maybe it will be fixed in the future. Yeah, and so far, after all these challenges that we have, where are we? Looking back, it was a crucial decision to define that TiDB actually is our primary database, and that all new schemas go to TiDB. This decision helps us with convincing developers that it is important to invest into TiDB, and they need to spend time on the migration process. After having this decision, we said that all new schemas go to TiDB, and yeah, it makes a lot of sense because otherwise, eventually, we have to migrate those schemas as well. And the third strategical decision was about migration priority. We made the list of schemas with operational issues based on 2 factors. It's data size and criticality. So basically, is the schema in a critical path of our applications or not? Yeah, and we have a lot of data migrated from Vitess and Percona MySQL to several TiDB clusters. We share TiDB clusters for around 10 schemas per cluster, depending on the load profile. after 18 months of active migration, we have some custom tools for migration itself, for backups, and for additional database and table level metrics. Like we actually would like to know how big is like exact table or exact schema to address some costs to developer team, to the developers. Yeah, and we have much fewer operational issues. So we, as I said, we don't need to care anymore about details, about master switch and so on. Yeah, we have a very heavy load at CDC. We replicate almost every change in database to the data lake. Yeah, and it will be impossible actually without TI/CDC and Kafka support. Yeah, and what's next? So we're definitely happy with TiDB. We want to migrate more. We want to grow TiDB as a primary database engine and Bolt. After migration, some schemas, we found out that actually it will be very useful for give a try TI Flash for instant analytic queries. We also want to try Kubernetes operator and Kubernetes, maybe like starting from a staging environment. We also already started with TTL feature because we actually want to keep only operational data in TiDB and have everything else like in data lake. And since we are sharing TiDB clusters, we actually need resource control to avoid these noisy neighbors. Yeah, and to make performance more stable. Well, that's all I wanted to share with you today. And yeah, to sum up, business produces a lot of data, but it also like rely on data and to make data-driven decisions. MySQL and with much data, it may create some troubles. At least it creates some troubles for us. But what we see that TiDB and much data actually works and works pretty well. And I have like a few conclusions. Yeah, I also have a picture with lines. I have two straightforward ideas actually. By the way, this is Honey Badger. It's a mascot of Bolt, and it has like a special ability. This creature is fearless. And my first conclusion actually, don't be afraid of using new technologies, even if the area is very conservative, like databases. And conclusion number two, that support open source projects, participate in meetups, and communicate, talk to each other. And in case of any issues, please create GitHub issues or even GitHub pull requests if you feel strong enough. Yeah, that's it. Thank you very much. Questions? Oh, okay.
If we have time.
Yeah.
Thanks for the presentation, really great. What kind of solution do you use for your data lake or warehouse?
We use Presto. Databricks, Ahana, and yeah, Looker, whatever. Okay. To be honest, yeah, I know those buzzwords, but yeah, it's like owned by different team.
Okay. Yes. Thanks.
So 2 questions. First is a strategy. So from what level that the company make the decision for switch the DB to primary DB to TiDB? Do you have to get at least CTO buying for this? This is the first question. Second question, you talk about one of the challenge is the latency. I want to get a little bit more detail about how you benchmarking and define your SLO or service agreement in terms of latency and improve or monitor that. Thank you.
Okay. Actually, decision came from the bottom. Basically, it was started from our team because we experienced like more troubles than other. Basically, it was mostly operational issues. And that's why we pushed like to this decision, like from the bottom to the top. That's how it was. And about, yeah, did I get your question correctly? Yeah, okay. And the second question was about latency, right? So yeah, we have microservice architecture for our applications. And it really depends on application because like latency is important for some things, for order matching or for like some like not real time but like close to real time things. But for many things, latency is not so important, and yeah, we can live with that.
Do you mind sharing some of your transition or migration experience, first 24 hours, first week? Did you have how was the cutover? Did you have a downtime moving from from MySQL to TiDB?
Yeah, this is very good question. Thank you. And we actually have like a presentation from our first meetup where we, my colleague Susanna spoke about that. So we have proxy SQL as access layer before our databases. And we developed like our custom tool for do this connection switching from MySQL to TiDB. So for migration, actually, like actual switch usually takes I don't know, like 3 seconds. So it's downtime is something about that.
Have you gone through any version upgrades?
Yeah, we do, and yeah, this guy actually does it a lot. So we usually we prepares like spare cluster, do replicate like data from one to another, just in case. We never use it, but just in case we have this spare cluster, and we upgrade the real life cluster in place. That's how it works. Yeah, thank you.